Hello everybody, this is Richard from NilFactor, and I moved my mic here, I apologize, I should have done that sooner, but anyways, Richard from NilFactor here. Today we're going to be covering web application security. We're going to take a look at Cross Site Request Forgery and how to prevent it. So, yeah. What is Cross Site Request Forgery? I'm going to refer to it from now on as CSRF. It's also known as on-click attack or as session writing. CSRF is an attack that forces an end user to execute unwanted actions on a web application in which they are currently authenticated. CSRF attacks specifically target state-changing requests, not theft of data. So they can't steal your data with this kind of attack right out with that initial attack. They can use it to get your data later on, but not right away. Since the attacker has, and they can't get it because the attacker has no way to see the response to the forged request. I've gotten that explanation there word for word from this link, and so I just, showing where I got that source. So what is CSRF? Here's a theoretical example. It's a pretty simple example that probably can't happen on Facebook, but it's an example that will help you understand it. So you're logged in to Facebook. Either you have a tab open and you open a new tab, or you close a tab and you go to some meme website. You go to .com/funny-meme, whatever, but you don't log out of the Facebook page. You're still, so that session is still active. You click on a meme, and in the background it has a link to an image that isn't really an image, and you don't notice that it's a broken image because it's hidden, or JavaScript that submits the request to Facebook, and it causes you to post on your timeline saying something you had no idea about, and so it's whatever, and it's posted on your timeline, or it causes you to add someone as your friend, someone you didn't want as your friend, but it sent a friend request so that they can later accept it and get your data. So that's an example right there. It's pretty black and white. You just go to some meme website and you're reading memes, and in the background it sends this CSRF to some site you're authenticated to, and it performs an action on your behalf that you don't know about. Like I said, this example probably couldn't happen, so it's a little hairy, but you kind of get an overview of it. And in this tutorial, you'll learn how to do this and then how to prevent it from occurring. The reason why you want to learn how to do it is so that you can test your application that it can't happen. That's how you know it's secure, because you tried. And sometimes you have to learn the tricks to stop them. So how to stop CSRF. Your web server can be set up with cores. However, this isn't going to fix it 100%. There's people that believe that, but it's only up to your web browser to respect it. Your web server doesn't care. It's just something that, Apache sends with the request, and the browser goes, here's this, and then the browser goes, okay, I'm going to stop this request. But someone could have written an application that has a native written browser that they wrote, and it's accessing sites, and it could still trigger these cross-site request forgeries. The only way to ensure 100% that your application is going to stop it is a CSRF token in your web app. And this will be your greatest security measure you can implement in solving this kind of attack. It's very easy, very straightforward. And in most cases, you can simply, if your application is well written, you can simply, create a class to handle it, and it when the request is being handled by your routing or whatever, if it's a post, put, delete, this class will handle it. And you don't have to go code it 100 places if you have a well-written application. So what is a CSRF token? A CSRF token is a key pair value that you require to be submitted with all your post, put, delete requests. If you want to get technical, you could require it with some GET requests, but in that case, I feel that your application is poorly written. Well, not necessarily poorly written, but generally, if you want to change, update data, you wouldn't use a GET to do that. So just generally, you'll just need them for post, put, delete requests. When you create a session for your user, you generate a token server side for your user to use when making requests that create, update, or delete information. You embed it in the form as a hidden input during submission, or assign it to a JavaScript variable to be used with an AJAX request. And simply, you would do this because if you developed your application in a good way, you would have like a MVC kind of a deal where that you had the session information and you're generating a template based off X, Y, and Z variables, and you would just simply assign the CSRF token and assign that in your form, or if you're using AJAX in that template, you would just use JavaScript to set that variable. The token key is something you determine beforehand, and it's a name like, let's say CSRF underscore token. That's something that you can define beforehand. You could make it random. It's really up to you. It doesn't really matter. The example given here would suffice. Then your app randomly generates the token value when the session is initiated. It would be something like 1337 dead beef. It'd be more random than that, but that's just an example I like to use when generating random numbers. And so the token value would be assigned to their session, and you would then require this token key value pair for every request made by this user to create and update and delete information. If it's not there, you deny the request. You throw an exception because you don't care, because that if they were using your application properly, that would be there. And so this lets you know something's up and to deny that request. So now we're going to get to the fun stuff. I kind of gave you the overview of CSRF, what it is and how to stop it. And so now we're actually going to go through a lab, and we're going to show you how to do this and how to fix it. So just go to github.com/nilfactor/nilfactor-csrf-lab and clone that repository. What it has a Docker file for building an Apache web server vulnerable to this kind of attack, PHP code that is vulnerable to this attack, doesn't have any CSRF tokens yet, and it has an example class for how to handle CSRF tokens. And what we'll do is in this lab is we'll show an example of a CSRF attack, and then we'll update the code with using the CSRF token class for post, put, and delete, and then we'll show you that the CSRF is now denied. What you'll need to, if you want to do the lab, you need access to a machine with Mac OS, Linux, You can do Windows, I just don't have that example here. You'll need Docker installed. You'll need a text editor, an IDE, or whatever you use to edit code. You'll need a terminal window with sudo access depending on your Docker setup. A web browser. Alright, let's go ahead and do this. Alright, let's get started here. The first thing we're going to want to do is open our browser and go to the NoFactor GitHub and the NoFactor lab, and that's just github.com/NoFactor/NoFactor-CSRF-lab, and you want to go ahead and clone or download it. I'm going to clone it. I've already got the git clone here. So I'm going to clone the repository. I'm going to cd into that, and I'm going to cd into the lab part of it, and then we'll go ahead and open up the code here. And so we'll go ahead and we'll look at the lab code, just the index.php and the htaccess here, header set origin control. I've included both the config and the htaccess. You don't really need that, but I did. So anyways, here I debated when creating this whole how-to of I really hate this code. I'm kind of embarrassed of it because it's so messy. I could have written classes and had some kind of framework to handle this and having templating, but you know, for our example here, it does the job. So let's go ahead and build our Docker container, and depending on your Docker setup, you might have to do sudo. I need to do sudo. I haven't set it up for this user to just use it, but so I'll do sudo, and I want to build, and I've already have all these here for you. If you are not familiar with Docker, just to give you an easier leg up here. And then so now that our container is built, we'll go ahead and run that container. And what that does is it created a web server for us on 127.0.0.1 and port 8000. And so we'll go in here, and you can see here our awesome little form. And so I'll just enter my username, some password, Richard W, and Richard at nofactor.com. This is my bio, and then I'm going to hit save. Okay, that never remember password. There we go. And so what you want to do is you want to go in here, click up here, hit enter, because like if you hit save and we refresh this, it's going to ask us to resend, and you won't get to see the example. So just click in here, and you can see here that it saved it. If I do so my bio, more stuff, you'll see that when we go here, it's there. So it's saving that in our session. And so now we'll go ahead and look at this attack code, and we can just open it up in our browser. I was going to put an S3 bucket, and I decided against it since I said that. So here's our funny meme HTML. It contains an iframe, which is hidden, and the actual meme. So when you go and look at this in a browser, you're not going to notice any attack. It's just going to show you the meme, and funny, way too funny. So you go to this attack HTML here, and you will see that there's a div with a redundant display none, just to make sure. depending on the browser you're using. And there's a form here with hidden inputs that will change our user's account information. And once that form finishes loading, this attack HTML finishes loading, it will submit the form. So pretty basic script there. So let's go ahead and open that here in our browser. And so see, it just looks like a normal page. You wouldn't be able to tell that there was anything going on. And if you reloaded this page, you'll now see that they have essentially stolen my account. If this was a real site, they would have been a profile update, and now they would have my account. I couldn't reset the password because they changed my email. And yeah, so this is something we don't want occurring. We need to stop this. And so I have written this handy dandy little nil factor CSRF token class. Comes complete with tests. Test driven development, folks. That is the key. So we will go over this code. It doesn't do any session handling. You're going to want to do that in your index, well, in this case in the index.php it handles it. But in your code you would want to handle the session stuff outside of here. This only has one purpose, and that's handling, verifying that the request has what we need. And so there's a const here of key name, and that is just CSRF underscore token, and that's what we need posted with our data. So it needs to be an input, or it needs to be sent with the data, with the value. And here is another constant of immune methods, and it just only has get in it. If you wanted to alter it to allow, other methods to not get checked, you could do that. There's a force new token constant, and that would allow you to require it to generate a token with every request. Now this is the most secure, but it's a little overboard, because if I was over here and I had multiple tabs for this server, you would have conflicting tokens, and your customer would see errors. So in most cases you don't really need that, so we'll just leave it false for now. And then the functions we really care about, we don't care about this one necessarily because it's all handled here, but this is just another way if you wanted to, for whatever reason, run that function. I have a use case for it, so here we go. These are the functions we care about. We care about handle session and get token. So we'll go over here, and we will copy the CSRF token nil factor to our code. And so now if we go in here to our code, see that it's here, and we'll want to go into our index.php. And just do a require once. Nil factor CSRF token.php. Make sure you copy the file if you're doing this lab, otherwise you're gonna have problems. Alright, so this handles CRF tags, allowing by requiring a CSRF token with all non-get requests. So So the first thing we need to do is no factor cserv token handle session. I think that's right. Let's verify. Handle session. All right. Just copy and paste it just in case. Got it open twice. And then we want to set our key, which is going to be no factor key value, and we want to get our token here. Goofy me. And it's get token value. Just verify it again. Alright, so now if the attack happens, what's going to happen is if for some reason the session expired, our user is going to see a stack trace or like a 500 error or just a blank page depending on our Apache setup. So what we're going to want to do is put this in a try catch. Of course. And E exception E, and we'll just simply do echo cserv token error, and then we'll just go ahead and return true because we don't want the rest of the code to execute. We just want it to stop, and we don't want our users to see this, some gobbledygook or a weird error that's hard for them to decipher. You know, if they call support and say, oh, I got a cserv token error, you have a good idea of where to look. So we've added that. We've got our key and our token set, and so we'll want to go down here to our form and add a hidden element. Type hidden name key and value equals token, and go ahead and save that. So now what we want to do is redeploy this, and we'll need to bring our Docker container down. So just do sudo docker remove -f. The -f just tells Docker to force remove this because it's running right now. cserv _lab. Lob. Dyslexia gets me every time. Alright. Okay. And so now that's done, we'll just do a sudo build. It will rebuild our container. And then sudo run. And it will run it. And now, if we come back here, it'll be blank because, oh, Jesus, I failed. So I'll go back to our index.php, key value, key name. I apologize, folks. I should have checked there. So I'm just going to do everything we just did again. Alright, so that is done. And now you see it works. Okay. So I'll enter my username, gobbledygook for the password, Richard, Richard, no factor. Can't change this, dude. And then I'm gonna hit save, and then once again, just to verify, click in there, hit enter. Yes, see. Alright, and then we'll go to our, let's just do this, so I can show you that what's occurring here now. So I'm gonna reload, and go here, and you'll see now that it got a cserv token error response. and you could verify that my user account is still good. See, so that attack did not occur. It was stopped by the CSurf token class. So I hope that this lab helped you kind of understand what a cross-site request forgery attack is and why it's important to stop it. And just enabling CORS is not the way to go about it, because there's no guarantee that a browser that someone's using respects that CORS, whereas Firefox, Chrome does, but there's no guarantee. So you don't want to rely on that, and so you just want to implement the class that we implemented, and it will take care of it. It'll make your application more secure. And in that use case, if you were using a framework like like an MVC framework in your router, you would just simply put all requests through that CSurf token class, and you don't have to put it at one spot, and it's like a few lines of code, and in each of your templates you would just need to put that token key pair value in for submission. So and that will stop the attacks. There's no way for the attacker to get that code. And yeah, so I hope you enjoyed it. Please stop by DaleFactor.com, hit the link to the Twitch and the YouTube pages if you like this tutorial, so you can follow us on YouTube and see new videos as new tutorials come out, or you can follow us on Twitch and see live sessions. Yeah, I really appreciate you stopping by, and I hope you have some happy coding and you learned something. Have a good one.